This is the second episode of Radio Bidar in English. Salah is here to assist us in understanding each stage of software development end to end.
Thank you, Salah. We have a Zoom meeting on the Bidar. Salah from Calgary. This presentation about software product end to end. Salah, please introduce yourself. You're very welcome. And then your presentation. What is the software product end to end, and what can bring from this session?
Okay. Yeah, so hello everyone. I'm Salah Abdelnaby. I'm a staff software developer at TDK InvenSense. I've been working in the industry for 8 years, I would say. I will introduce myself in detail in the next slide, but I will just talk quickly about why I chose this title. That title summarized my experience in the software development, I would say. So I have been into multiple stages of software development. I did I participated in several different tech stacks. I did do a back end, front end slightly, embedded systems, pipelining, which is DevOps. So I passed through multiple departments or multiple teams in my company. Because I work in a relatively medium-sized company, so that allowed me to jump between departments. I will go through that in the next slides and how this is happening. So basically, I would summarize my experience for today in this presentation, and definitely with the questions after the presentation. So that's the reason I chose that, because I assume that I got enough experience for me to be able to share it with others about the software product end-to-end, about big system, complicated systems. So this is the reason I picked up this title. So for today, I introduce myself already. I will introduce myself again. We will talk about the software product cycles, but not very abstract. I will mix it with my experience and what I have seen so far in the industry. I will share some management tools that we use usually day to day to do our development in the company, and how the product goes from, I would say, from idea to a product eventually. I will give an example of software product that covers several tech stacks. I will share some some different tech stacks, and everyone's now probably talking about software development with development and machine learning or data science from that perspective. I will go very low level to the hardware levels, how to program hardware, how do we deal with the hardware, and how do we get from hardware level to a cloud level. I will go through that. And then I will give some example about the market, the skills and things for the market, and how end-to-end software development is needed in the market, especially for the startups and small companies, that they need someone to be able to manage between or have flexibility, for example, between the tech stacks. So first of all, I have a bachelor degrees from Egypt, from AST, Arab Academy for Science in Electronics and Communication. And then I got a scholarship at Queen's University to do my master's in electrical engineering. So I did Master's of Science in Electrical Engineering at the Electrical Engineering Department at Queen's University. And then I started my career as a senior algorithm designer in the R&D department in a leading navigation company. After 3 years, I got promoted as a staff algorithm designer. And then I moved to the cloud team. Before I moved to the cloud team, I spent some time in the mobile apps team. And then during my experience in the cloud team, I did front end and back end, but mainly back end. I'm not a big fan of the front end. And then I became a release manager in my company, beside my work as a technical like the technical developer or doing technical work. That's beside my technical work. I believe that I have hands-on experience in the product end-to-end, and I will explain what do I mean by end-to-end for now. So I love teaching, and my hobbies is soccer and table tennis and snowboarding. So before I get that, I would like to share something that I'm proud of. So my first 5 years in engineering, I did electronics and communication. So there was a programming, but not like very, very low programming. I would say very minor programming courses. And the programming courses I took was more mainly for hardware, so mainly C and C++. A couple of courses probably during the 5 years, and then I did my master's in electromagnetic engineering. So I was in a big lab in Queen's University, or a popular lab at Queen's University. So my master's was about RF and antennas. So that's a pure electrical and electromagnetics. It's more related to the physics than it is related to programming. So during my 2 years of master's, I definitely took the courses. I published multiple research and journals, I would say. And after I graduated, or before 4 or 5 months before I graduated, I realized that there is no hardware chances or opportunities in Canada. Most of the opportunities are in the US. So I had to make a decision of shifting my career from being an electrical engineering or an antenna designer or RF circuits designer to a programmer somehow. So I had the title that I was in electrical and computer department, but I didn't know much about the programming. I was trying always I have been trying to learn programming, but it was very tough, specifically that I usually target the hardware languages or the low-level language, C and C++, which are very complicated because that's close to electrical engineering. So this is a language that I used to target. And eventually I made it to R&D development in that new company, in a small company in Canada, or a medium company in Calgary. So I was hired in R&D. I would say I learned everything from scratch: C, C++, couple of years C++, couple of years Android, Kotlin, and Java, and then JavaScript and Python, backend, and AWS. So I went over the whole stack from the hardware level, low-level languages to the high-level language, including the DevOps, the DevOps part or the pipeline part. So this is what I wanted to share, and I will go for the next slide, which is software product cycle. I think most of us familiar. This is a picture from Google. There was some addition I added here, but it looks like they are gone. So I will focus on them in my presentation. So the first thing that we usually do is analysis and all of this abstract conversation about product owner, product manager, business analysis, CTO, and blah blah blah. All of those guys, they sit together and start to give ideas and start to dream about the product, and then we go into the design phase. The design phase, we can say that it's software architect, and UX and UI. But I don't want to target only the software development and the web development. This layer can have products like sensors or hardware unit that will be deployed that will be added or put into an oil and gas company that has multiple sensors. Those sensors are continuously collecting data and receiving data, pressure sensors, and for example, accelerometers, gyroscopes, motion sensors. Those sensors together, all of them, they have to be programmed into a board, and that board is responsible for handling the data that comes, the huge number of data that comes from all of these sensors together without problems. So that introduces a low-level programming, which is mainly done by C. So this is basically getting microcontrollers and start to program those microcontrollers or those those computers to handle all of this data that comes from the sensors. Most of these sensors, they only can execute C or C++. So that layer involves lots of low-level language programming, C and C++. It also involves multi-thread handling, lots of interaction between the software and hardware, and usually need to manage the capabilities between the software and hardware. And that piece is usually also needed to be connected to the internet. So you can imagine that you are writing a driver, a Wi-Fi driver, or a Bluetooth driver, or a Zigbee driver that you're writing in C on a microcontroller that will receive data from multiple sensors together. And you need to handle all of that in C or C++, because there is no Java, there is no JavaScript, there is no Python. You are only limited to hardware languages or embedded programming. So that layer, what we call it in software development, is firmware layer, or that requires firmware engineer. That engineer or that developer will need to program those hardware and those sensors to interact with each other smoothly. And then the next layer will be uploading this data somewhere that we will do multi-processing on it, or we will process it, or we will save it, or we will visualize it. So just for this layer of design, I wanted also to explain and extend to the level of, it's not only UI and UX and architecture and that fun or nice stuff. It will be a little bit complicated of sensor design and hardware design and software design that involves lots of low-level programming languages to be done at this layer. And then for the next layer, that comes to the product. So the product has the units that will be responsible for data collection or data acquisition from other sensors. And then the next layer will probably be uploading those data sets. So you have to manage also the connection to the internet through the Wi-Fi or other options that you will have. After that, you take all of those data sets or all of those data uploaded somewhere to the cloud, here where the backend comes. Usually there is an endpoint that you hit with the data set that you would like to upload that hits somewhere in the cloud. We will get to it later. And then once it hits that location on the cloud, some processing will start to happen in those data sets. All of that is designed automatically. So the development can be a low-level development, back-end development for data uploading. And then after doing some processing on this data set, we can come to the front-end part of the project, which is visualizing the results or the analysis of the data. So that's the design and the development. When it comes to testing, there's no magic here. In addition to what we usually do for the front-end testing and back-end testing, we do a pipeline testing. So we make sure that the pipeline is working properly. The events or the process event after event is being handled properly. So there is no need to think about missing a step. The good thing about the cloud is there is always backups that being handled by itself. You don't need to worry about backups. So for today, I will talk more about AWS services AWS as a cloud service, or we will get to it later. But now, if we can count during the stack that we mentioned, we can talk about firmware engineers, front-end engineers, back-end engineers, DevOps engineers, or developers. The engineers now mainly engineers/developers. This is the thing. So we are talking about 4 types of learning or 4 types of opportunities or fields that created more opportunities for the people in general to learn programming. Whoever is interested in one of those, have a chance definitely to work in one of those companies who need those jobs. So, and then the next step that we talked briefly about is testing. So testing is also very big field, I would say. There is software testing, hardware testing. and there is also a physical test. So software testing is basically you're sitting at home writing test cases for front end or for back end. You're using some tool for the front end like Selenium, or back end like Postman, or writing your test cases in Python. All of these skills that need to learn if you would like to work as a software tester. So for the hardware part, it comes to testing the hardware. So for the programming, low level programming language, you usually test it with the hardware together. So you try to test the C part or the C modules that you created, but also you would like to test it, how it will perform on the hardware. So here where the physical testing comes. So you will need to connect the sensors, make sure that you cover all of your cases, run the sensor by itself. What if one of them disconnected? What if there's something happening in the multi-threading between both of them? How to handle a rate error? For example, you are assuming that you will receive data every 1 second, but for some reason, just you got data every half second. So this kind of problem that happen in the software that cause complications and the problems. And then when it comes to deployment, eventually you would like to take that code and put it somewhere on the cloud, and then the cloud will be responsible for the process. Maintenance and testing and support managers. So maintenance is a big chunk of time that we will take. Design doesn't take that much. Development does take time, but maintenance is a big. So most of the companies hire people only for maintenance, because maintenance can be very, very expensive and can cause multiple problems. And when it comes to POCs, you can pass proof of concept to the company because there's no maintenance for the product, or the maintenance is very expensive. For example, the code is written in a bad way that consumes the developer's time to maintain. So we move to the next slide. Yeah. So this one is we'll talk about the management tools. So for me as a release manager, I deal with Jira a lot. So I manage the sprints, the user stories, the effort will be needed for the development. So basically, the product owner starts to write the user stories. This one comes to the planning tickets. We start to break them into engineering tickets, technical tickets. And then those technical tickets, they start to be moved to the team leads. The team leads, they start to distribute that on the developers that they have. And then we usually manage the whole release. So for example, there's a ticket about developing a back-end protocol or a back-end for uploading data sets. In that case, that's a user story that we write what we expect, and then we take it into a planning ticket, and then eventually it comes into multiple tickets, engineering tickets. Someone will create the API, someone will deal with the cloud, someone will deal with the permissions, and so on. So we start to break them into engineering tickets that they get assigned to the engineering accordingly. So other tools that we deal with are like source control, like GitHub. So we usually link Jira with GitHub to have, for example, to connect the development brand to the ticket itself. So that helps and makes life easy from the management perspective to manage the project in general and to know which development related to which ticket and who's did what and how long did it take the developer to do that. And then we have the mockups. So for front end and back end, you can always, or even for the sensors layer or low level layer, you can always add prints, add drawings, or design UX or a UI, design the UI, or assume a flow of the code, how the code flow will go, and add to those print screens to those tickets. So everything's connected together in a tickets that is linked to a planning ticket and user store user story. So everything's connected together from the product management to the developer eventually. And then usually before every release, you have an internal demo with other teams that give you the feedback, or the quality team, or the stake, and then an external demo, for example, for the stakeholders for the layer above, just to show them what the work and this is what we expect or know, and what is the feedback on it, and so on. So that's the example that I mentioned at the beginning, that you can have a hardware piece or a hardware system that you have it somewhere that controls multiple sensors. And those sensors, when you choose a language, to make sure that you choose a language that can be deployed on multiple platforms. This language can be integrated with other languages. So for example, sometimes we integrate C with Java because we design our core libraries or algorithms in C. And then we would like the piece of the code to run on a mobile phone. So we start to integrate C and Java together through a native layer. This is Java native layer that converts the Java objects and Java methods into a C, so we'll be able to call them. For the design itself, the design is not always going back one way, so you can always send the data and receive callbacks when the data is ready or when the result is ready. So that's all being designed at the very beginning based on the programming language and the frameworks that we will use. And again, how to access this data, how to save it. We will save it on. It depends. Some people definitely use AWS or Azure and so on. And then data processing, you have a piece of the code, the core of the company. For example, like oil and gas company that generates or that has a product that analyzes the sensor that comes during the drilling process. So in that case, you get all of the sensor data, and then you would like to run all of this data on a program that will do analysis and machine learning and so on. So that's usually the case. And then we come to the visualization of the results and controlling the sensors. Those sensors you might need to change the rate or whatever. So okay, so we can move to the next. I would like to go through the information that we mentioned, or the levels or the stages that we mentioned through the specters. So this is the firmware development part. Levels is multiple sensors and the board or microcontrollers or computers that gathers all of this information from those sensors and then to upload them, and then we do some processing, and then we do visualization. So the jobs that are involved, like the job that's needed here, is embedded system developers, firmware developers, and low-level language developers, and definitely designers. That's from the software perspective. From the hardware perspective, you also need someone to be able to design hardware, someone who has understanding of putting together things in hardware and design the PCB, the printed circuit board itself, and doing all of those connections wired on the one board and print it or send it to be printed somewhere and design it. Usually people just try to get the processor from somewhere and design their own board, so they know when, for example, if they will need an Ethernet, or know what kind of antenna they would like to have, the power of the antenna, and so on. And the size also could be problematic in some cases. So the next layer is more software layers, involves the cloud part, which is this piece. It can be done by AWS, on AWS or Azure. It definitely involves backend development, some services like Lambda, database, S3, and so on. When it comes to processing the data sets, the core engine of the company, the product itself, for example, that detects the faults in some sensors, the faults of the process, or faults in the machines and whatever. Those designs are event-driven design. So event-driven designs means that the data sets will get uploaded by itself. Some processing will be done, and then the user will be notified when this data is done, or the data sets or the analysis will be sent somewhere. The AWS services that can be used in that case is ECS or EC2 or Docker. Definitely, Docker is one of the things that we usually do. When we do a software, we need to package it in a way that can run on any computer with no problem. So when I deliver software to a company, I don't expect them to download or to manage dependencies. So I give them a Dockerized image or an image Docker that they can take it and run it automatically with no problem. Visualization is a fun part of the project. That's the front end part. We can use for the visualization Angular or React or some other new things that comes every day to the market, I would say. So the controlling sensors, the other part can be a back-end part. For example, controlling the sensors, those sensors, the rate, the scanning rate, how many times do you get data from those sensors? You'd like to disable one and enable one and so on. You don't need to go to the site and remove the cable of it. You just need to probably some ideas like having every day or every couple of days. You need to check the settings and configuration that you're getting from the cloud, and then based on this configuration, you start to enable or disable or speeding up the process. So yeah, let's have some questions. So do you guys have any questions?
Yeah, awesome, Salah. Thank you so much. It's very interesting topics, and it's very interesting your background. I'm very wondering to your background is hardware and yeah, software. You studied software.
Bye.